Identify all types of symmetry for the graph that's shown. Is it symmetric about the x-axis, y-axis, the diagonal line y equals x, the origin, or none of these? Well, let's first start off with answer choice A and see if it works. If we had symmetry across the x-axis, it would be the same above and below this dotted line. And it's not. If it was symmetric about the x-axis, we would have this section over here, but then we would have another section going down this way. So that's why it's not symmetric about the x-axis. Is it instead symmetric about the y-axis? Well, if it's symmetric about the y-axis, you would have the same pattern going from right to left as what's shown left to right here. So it's not symmetric about the y-axis. Is it diagonally symmetrical about the line y equals x? Well, let's actually draw that in. This symmetry definitely does show, because if we were to reflect this graph across the line y equals x, this 1/2 comma 2 corresponds to 2 comma 1/2. Similarly, -3 comma -1/3 would correspond with -1/3, -3. So this one definitely works out. Now let's look at the symmetry about the origin. Symmetry about the origin means if you were to take this section of the function and rotate it 180 degrees, it would directly map onto the other side of the function, or the function would directly map onto itself from both sides, and it does. If you were to actually take this function and rotate it 180 degrees, you would end up getting the same exact graph. And I'll try to show it. If we do a 180 degree turn, it looks identical. So when it is symmetric about the origin, it has rotational symmetry. So it's clearly not none of these, because we already have these two answer choices. So C, the diagonal y equals x, and D, the origin. It's also worth noting that this special function is also symmetrical about the line y equals -x. If you were to reflect this function about that line, it would map onto itself.